In this video, I'm going to be making this for my 104 class at IUK. It's going to deal with problem solving using a system of linear equations. I've made a series of these videos because I'm only making one story problem per video. They are going to cover the types of problem solving that you're going to encounter in section 3-2A and 3-2B. Alright, now for this one, unfortunately, I don't believe I'm going to be able to get it all on one piece of paper because of the approach that I'm going to take for writing the system of equations on this one. Okay, now this one's going to deal with uniform motion. Alright, so we're going to have a couple of, you're probably going to encounter a couple of these type of problems where you talk about a tailwind and a headwind. Alright, so something that this particular story problem deals with flying. Okay, if you're flying against, if you've got a headwind, you're flying into the wind, it's going to slow you down. If you are flying and you have a tailwind, then it's going to speed you up a little bit. So that's kind of what this takes into effect here. We're still going to go through the same procedure we always have. We're going to define our variables, we're going to write a system of equations, and then we're going to solve either by elimination or substitution, whichever one happens to be easier. Okay, so on this one, let's go ahead and read it first and then start defining our variables. It says, suppose you fly from Miami, Florida to San Francisco, California, and it takes 6.5 hours to fly 2,600 miles against a headwind. Okay, so against a headwind, it's going to slow you down. Okay, at the same time, your friend flies from San Francisco to Miami. Her plane, it's a typo, travels at the same average airspeed, but her flight only takes 5.2 hours. Okay, that's because she had that tailwind that was helping her go faster. Okay, find the average airspeed of the planes, find the average wind speed. Okay, so it's asking us actually to find two things, so we're going to define our variables that way. Alright, so we're going to let, actually for airspeed and wind speed, let's go ahead and use A and W. I've been using X and Y in all these, but on this one it might keep things a little bit straighter if we actually use an A and a W. Alright, so I'm going to let my A be airspeed, because that's one thing I'm supposed to find. I'm going to let my W be the wind speed that I'm supposed to find. And technically I could use X and Y here, it really wouldn't make any difference, but this may make a little bit more sense, easier to keep track of. Okay, now to write my system of equations on these, I usually use a table to organize my information. Okay, now we all know, hopefully we all know, that rate times time equals distance. Alright, distance is equal to rate times time. Alright, which is a pretty common thing dealing with speed. I can do that in any order. So if I can figure out the rate and I know the time, then that's going to give me distance traveled. Okay, rate times time equals distance. So what I'm going to do is I'm going to set up a box. Alright, I'm going to have two scenarios. I'm with the tailwind and I'm with a headwind. So one of those two things. So let's do with tailwind. And then let's do with a headwind. Whoops. Let's fix that there. With a headwind. Okay, so there's my two scenarios. Okay. Now when I make this table, what I'm going to do is I'm going to use this formula and I'm going to go left to right. I'm going to say, okay, here's my rate, and then here's my time, and then this is going to be distance traveled. Let me just put distance. Okay, so what I'm going to do is I'm going to go up to the story problem and I'm going to fill in all of this piece of information in this box. I believe we've used this distance equals rate times time formula before in my 104 classes. Alright, same concept. If we can fill in these four usually, or maybe even all of them, just depending on what they are, it's going to help us write our system of equations. And on this one we are going to, since we do know the distance traveled, which is 2,600, we're actually going to be able to fill this in. So we'll be able to fill in all of these. Alright, so let's go back up here and pull out the times. Okay, so 6.5 hours to fly. You're going from Florida to San Francisco, so that's going to be with the headwind. Alright, and that was 6.5. Alright, flying the other way from San Francisco to Miami, it only took 5.2. Okay, because that's with your tailwind. Okay, so you're gonna get to go faster. We know that both flights are 2,600 miles. So 2,600 miles. And then we're gonna have our rate to deal with. Okay, now with the tailwind, it speeds you up. With the headwind, it slows you down. So your airspeed, all right, plus the wind speed speeds you up. Okay, because it's with you. You got that tailwind, it's pushing, it's making you faster. All right, with the headwind, it's going to slow you down. So your airspeed minus whatever the wind speed, and it's ultimately going to slow you down. Okay, so now from this, since I know rate times time equals distance, I can go straight across here and I can write my system of equations. All right, so this times this. All right, 5.2 times, this is a binomial, a plus w is equal to 2,600. All right, same thing here, 6.5 times a minus w, and that's 2,600. All right, so here's my system of equations. All right, now, that system of equations, I could distribute the 5.2 and the 6.5, all right, but then I'm going to be working with a lot of decimals that is just not necessary. All right, so what I could do is I could solve those equations. I could take this, all right, and solve this equation. Like I could divide both sides by 5.2 and I could divide by 6.5, and if I do that, then it's going to make both equations a lot easier. So if I divide by 5.2 on this one, and if I divide this one by 6.5, okay, that's going to leave this top equation as a plus w equals 500, and the bottom one is a minus w equals 400. And that is a much nicer system of equations for us to solve. Okay, so what I'm going to do is I'm going to take that system of equation and go to another piece of paper and we'll finish solving this. Okay, taking that system of equation, I will rewrite. We came up with an a plus a w equals a 500, and we came up with an a minus a w equals 400. Okay, so because of that, we want to solve this. Again, I think I'm going to use elimination method because normally under normal circumstances I do substitution, but this is just too nice not to use elimination. All right, so I am going to use elimination. And actually, I keep calling it the elimination method. In my particular 104 class, the textbook calls it the addition method. It's the exact same thing, just a couple different names for the same method here. So a plus w equals 500, a minus w equals 400. All right, if I'm doing the elimination method, I'm going to add those two equations. These two are going to fall out right away, eliminating those variables. Adding going down, I'm going to have a 2a is equal to 900, and then a is equal to 450. All right, so once I have an a, we said a was airspeed, so there's my airspeed. All right, now I need to go back in and find wind speed, so I'm going to substitute back into my first equation. Right there is going to be the easiest. All right, so substitute. Well, it helps if I spell substitute, right? Substitute back into first equation. Alright, so I had an a plus a w equals 500. I now know that a is 450, so 450 plus w equals 500. That makes w at 50, or my wind speed at 50. Okay, so after I get done with this, I always write a little summary here. So we had to find airspeed and wind speed. Okay, so airspeed was my a variable, which was 450 miles per hour, and the wind speed is 50 miles per hour. Okay, so definitely a little different approach on this one than we had been doing in the others that were in this section, mainly because you're just dealing with that headwind and tailwind and it affects different things. So this is possibly, one type of problem that you could encounter dealing with this uniform motion. Definitely thanks for watching. If the videos are helping, don't forget to share with your friends and subscribe to the channel. Thanks.